Chapter 2 Descriptive Statistics 2.1 Collecting and Organizing Data. A statistical measure.
Right, so looking at the question, it shows the number of orthodontist visits per year made by the students in the 10th grade. So based on this table, they want us to find the mode, the median, and the mean. For the mode, it refers to the data with the highest number of frequency. So by observing this table, we can see that 12 is the highest frequency, and the number of visits with the frequency is 12. So the mode is 12 visits. As for the median, it is half of the total frequency and where that value lies within the range of that value. So the total frequency is 36. You divide that by 2, you will get 18. And 18 lies in this range where the number of visits is 10. So the median will be 10. As for the mean, we can use our GDC to find out the mean. So first of all, put all the data in a spreadsheet where you separate the visits and the frequency. After that, you press menu, you go to statistics, that calculation, and one variable statistics. Press that, ensure the number of visits is 1. For the X list, you should put visits. As the frequency, you put frequency. Press OK, boom. Your mean would be the X bar, which would be 8.944. So that's your mean. After that, they want us to find the standard deviation and comment on it. The standard deviation is also given with sigma x. And over here it shows that it's 4.09. When they ask us to comment, the standard deviation is related to the spreadness of data from the mean. So we can see that the spread of the number of visits from the mean is 4. And find the range, and in quartile range is the final question. So as for the IQR, you can go open a new page and you can press variance Q3, which refers to quartile 3, minus Q1, which refers to quartile 1. And your answer would be 6. That would be your interquartile range. As for the range, we take the highest number of visits minus the lowest number. So we can see it's 40 minus 0. So the range would be 14. And they want us to comment on the spread of the data. As the value of the interquartile range is smaller than the value of the range, we can assume that the range of values of the data is more tightly around the mean in the interquartile range, compared to the range. That is all. Thank you, and I hope you understood.
2.3 Ways to present data.
Next is cumulative frequency graph. In this graph, x-axis consists of the upper bound of the data, while the y-axis is cumulative frequency. The frequently asked question about this graph is usually interquartile range, first-centered quartile, and also median.
To find the first quartile, 1 over 4 times the total frequency, so we get 30. So we annotate the graph to find the first quartile, which is we got 119. To find the third quartile, 3 over 4 will times the total frequency, which is we will get 90. We will annotate the graph to find the third quartile, which we will get 132. To find the median of this cumulative frequency graph, we just divide the total frequency by 2, so we got 60, and then we annotate to the graph, and then we will get 125.5.
Box and whisker plot. So what exactly is it? It's a way to show the spread and centers of a data set. It consists of minimum value, first quartile, median, third quartile, and maximum value of data set. To construct your own box and whisker plot, you must first find the median, the first quartile, the third quartile, the minimum value, and the maximum value of the data set. Next, you must determine if there are any outliers in your data set using the formula shown above. Outliers are not included in the plot. To sketch your own plot, you begin with the first quartile, the third quartile, and then draw the median. Next, you will write down the minimum value and the maximum value of the data set. In cases where there is an outlier, you draw the plot normally. However, you must change the maximum value or the minimum value to the number that is the nearest to it. In this case, 54 is the largest number after 76 and is selected as the new maximum value.
2 point for bivariate data.
Here, 2.4, example number 9. The results of 10 students in the final mathematics and physics exams are given. As you can see, the table is given to us, so we have to do one thing before another, before continue answering the question. First thing first, we have to put in our data into the calculator. As you can see here, I have put in my mathematics data and physics data and another one. Okay. And then plot the information on scatter diagram. First, we have to add a new page. Okay, add a new page. Add data and statistics. And what we have named here, M and F. An x-axis M, physics, the y-axis. And there we go. We got the scatter diagram. And B, plot the point X bar and draw the line of best fit. X bar and Y bar is actually the mean of X and mean of Y. So we can do a two variable statistics here. Menu, statistics, and two variable statistics. We take M and F. Don't confuse with your variables, okay? Here we go. 70.8 for X bar and 75.6 for Y bar. Here, we cannot put in the value. So what we have to do is we have to make a best fit line. Max best fit line. Analyze. Menu. Analyze. And then regression. Best fit line is also the regression line. Okay. From the line, we can trace the line using graph trace for A. Okay. 70.8 and 75.6. 70.8. 75.6. Okay, here we go. That's it. And then the next question. Predict the physics result for a student who scored 65 on their mathematics exam. Yeah, we're gonna do the same things. 65 for M. Where? 65. Okay, 65. Yeah, here we go. 65.0. 65.062. Next, here we get to physics results 71%. Okay. And then the last one, D, state whether or not the results indicate that students who are good at mathematics are also good at physics. This one, we have to look at our PMCC value, the R, that we get from the two variable statistics here, where R value is indicate our correlation between two different variables, X and Y variables. Okay, here we get 0.93684. That is strongly positive correlated between each other. So the analysis and the conclusion is that mathematics results were strongly positive correlated with physics results. As you can see, we can know as roughly on the graph, but here we have to look at the R value. Okay.
Thank you.